So with that, guys, what I'll do is I'll start the quiz of say the chapter, or what you can say, the first section that we did. Okay, so guys, the first question, I think we have already done a 3-question quiz, so this is slightly more than that. So please kind of participate. So what terms from the list below would be viewed as the benefits of using cloud services? Okay, so you have to choose 3. So
Yeah, it would be in the
Agility.
agility and economies of scale.
okay, agility,
Like is it
someone said. Yeah.
is
And why economies for sale, guys? Do anyone remember like what we talked about economies of sale? In less we would be doing more. So with cloud we can do more by just doing less, because it is like a wholesale provider. Cloud providers are like a wholesale. So if we take our products from wholesale market, that's more cheaper, right? Similarly, if you take it from cloud, it's like taking it from them, and it is going to be cheaper. And then so it can be economy. So will it be also unpredictable cost and local reach only? Can these be
Uh,
the answers?
no, Yogesh.
Okay, cool. So guys, I think let's keep this now. Then when looking at using cloud services, what expenditure type are cloud services based on? I think CapEx and OpEx, everyone understood, right? So is it CapEx, OpEx, or is it friendly expenditure, or is it maximum expenditure? Anyone?
It's
Eh,
OPEX.
Yeah. So is it Nusrat? Was it Nusrat?
No, this is Shubhra.
Oh, Shabnam. Okay. So
Shubhra. Yogesh Shubhra here.
oh, Shubhra. Okay. Yeah. Thanks, Shubhra. So, but anyone feeling that it is capex, guys? Just so there is no difference. It's very clear to everyone that what is the difference between a capex model and opex model, right? So why it is not capex? Anyone want to tell?
Yeah, because cost is fixed in capex as you told in the last session. So for us, it's like a pay as you go model for clouds. So it's a
Yes.
more of a opex model.
Right, and we are not paying anything upfront, right? We are paying. We are not like purchasing a server. We are just renting it out. So it can't be a capex. It has to be an opex. Okay. Then the third one: which of the following terms relate to making a service available with no downtime for an extended period of time? So is it performance? Is it high availability? Is it fault tolerance? Or is it
High availability.
high
It's high
availability and fault
availability.
tolerance.
Fault.
someone said fault tolerance or
High
high availability?
availability.
High availability.
Okay. So any difference between fault tolerance and high availability, guys? If you remember what we covered in the last session, what is the difference? So these all terms are very kind of, very near to each other. What is high availability and what is fault tolerance? So anyone wants to volunteer, or I can go and explain?
Well, the fault tolerance system does not have any means you can say no service interruption is there in fault tolerance, and in case of high availability there are chances that might services might get interrupted.
So in terms of like how I look at, or how it is basically is in terms of fault tolerance, and what they are saying is the service has to be fault tolerance, but at the same time they have to be resilient. So let's say there is a fault, they can tolerate and they can come up from it. That's what fault tolerance. So it doesn't mean that they can be faulty, because it's such a big heterogeneous system, so many things connecting to each other. So it can't be really given a guaranteed. But when we talk about high availability, what we are saying is. It would be there would be again downtime, but in short, high availability means that the maximum available time the service is up and running. And what fault tolerance means that it can go down, but then it can also come up. So that's how so in this definition, what we are saying is which of the following terms relate to making service available with no downtime for extended period of time. So with no downtime and for extended period of time. So that means it is high availability. Okay. Then on number 4, which cloud models provide services that can be accessed by public? And we have to choose two. So can anyone tell whether it's public, whether it's private, or whether it's hybrid?
Public and hybrid.
Public and hybrid. Any? Should we lock it, guys?
Yes.
What is this thing called as global? Anyone has heard this term?
It's nothing.
It's nothing. Okay, yeah. I think they have just tried to test our knowledge or skills.
It is
Okay.
just to confuse you.
Right. Okay. Then what is the next thing is which cloud model provides the greatest degree of ownership and control?
Private.
Private. Okay. Which is the most complex? I think okay. There is. I don't think there is a question around it. But which among the three is the easiest and which is the most complex, guys? Public, private, and hybrid.
Hybrid is common.
Hybrid.
Yes. And which the easiest I think is public, right?
Public.
Public.
Yeah. Then which cloud model provides the greatest degree of flexibility?
Hybrid.
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 Hybrid. Okay, good. Then you are running a virtual machine in public cloud using IaaS, which is infrastructure as a service. Which model correctly reflects how that resource is managed? It's a user managed model. It's a cloud user managed model. Then there's someone is driving. Hello. Yeah. So what kind of
It's a shared responsibility model.
so user management model, it can't be, right? Then it is cloud user management model, and then it is no responsibility management model, and then there is a shared. Okay, let's click shared. So guys, you are giving the answer. Okay. So any other thoughts? Okay, I think we'll then which term best describes platform as a service? So user can create and deploy an application as quickly as possible without having to worry about managing the underlying infrastructure, or users are responsible for purchasing, installing, configuring, managing their own softwares, operating systems, or user pay an annual and monthly subscription. So which one is this among the three?
A.
User can create. A1.
Okay. Okay. So what is this? What does this notify? User pay an annual or monthly subscription. What does this? Which type of service does this talk about? Which one?
Software as a service.
Yeah, it will talk. It is talking about software as a service. Now, which one this talks about? User are responsible for purchasing, installing.
Infrastructure as a service.
Infrastructure service.
Yes, right. Now the last question. Okay. So you have two types of application which you need to run. Legacy application that required specialized mainframe hardware support and can run on commodity hardware. Which cloud deployment model would be best for this? So you have two types of application. And there is also a mainframe or a legacy system. Which type of cloud should we use?
Hybrid.
On-premises.
Hybrid.
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 Hybrid. So someone said on-premise. So guys, whoever said on-premise, what was your thought about it? Like, why did you say it?
No, Yogesh. Hybrid. Yes, got it. On-premises means all the setup is in the same premises, means same office.
Yeah, actually on-premise, there is nothing like on-premise model. It is either public, private, or hybrid. So this is other example of this global like case. So there is nothing like global, right? There is on-premise, but I mean on-premise is basically a cloud infrastructure where we are saying that we are putting cloud services in private cloud. So that is basically it. So on-premise doesn't really. So guys, shall we check answers? Okay, so yeah, so this is the right answer. Then let's check this answer. So it is the right answer. Okay, then the next one, high availability or fault tolerance. So this is where people might have a divided opinion. So, but the answer has to be high availability because as I discussed. Then again on this, I don't think everyone, it was an unanimous choice, so no doubt about this. Which is this one, the greatest degree of flexibility. So ownership and control, sorry, this is ownership and control. So this has to be private. And what would be the greatest degree of flexibility, right? So anyone wants to justify which answer before I click check answers? Justify this point. Anyone? Has Nusrat joined, guys? I'm not sure if Asha was asking for that. Not sure. Venki, Vinay, how many people do we have? 22. The count has dropped. Okay. Pranav, you want to give this answer? Why it provides greatest degree of flexibility? Or anyone? I mean, I don't want to nominate any specific person, but anyone can. Hello. Okay, anyways, hybrid is the answer because we can switch either ways. Whenever we want public, we can go public. Then the next one is you are running a virtual machine in public cloud using as, what is this? So any thoughts before it is a shared responsibility model is correct. Again, pass should also be a simple answer. So it's also correct. And this is also going to be a simple answer. So, yep. So this is good. So we are how many minutes? Like we have 17 minutes and we have covered the first thing. So we quickly go to the second quiz, guys. So the second quiz, let me do it. Quiz of chapter number 2. Okay, this is going to be a short one. So next time we'll have a bigger quiz for chapter 2. We did so what is Azure? Okay, Microsoft Cloud Computing, which provides compute power storage over the internet using pay-as-you-go pricing model. A single data center located in Redmond, a hosting environment specifically for virtual machines. What is Azure?
A.
First.
A first.
Right. Okay, then which of the following is example of an Azure application platform? Azure App Service, Azure Load Balancer, Azure Table Storage, Azure Cache as Redis. I think we have not gone into the details of this yet because we kind of went the chapter number 2 very quickly and we spent most of the time in building a web service or an application service. But do you remember what can be the answer? Or do you think what should be the answer? Because it's talking about Azure application platform where applications can be deployed, and we actually deployed a application, a website. So which of these should be the answer?
App service.
App service.
Okay. Then when should you scale out your deployment? Scale out. Okay. So there are two types of deployment models. Anyone can quickly tell which are the two? One is scale up and other is scale out. So what
C3, third.
When you are using excess capacity that you don't need, when you need additional virtual machines to speed up your application, when your application or service requires a more powerful CPU. So guys, do you think it is 3 when you are using excess capacity that you don't need? So we are talking about scaling out, or we are talking about horizontal scaling. So horizontal scaling is what and vertical scaling is what? In vertical scaling, this is an example of vertical scaling. When your application or service requires more powerful CPU, this is vertical scaling, right? Or this is also called as scaling up.
I think C.
C, which is
because we need to scale up, so CPU, we need more CPU. So I think it should be.
So when you need additional virtual machine to speed up your, so scale out is an example of a horizontal scaling, guys. So A, B, or C is
C.
Are you sure? Okay, let's go with C and check what is going to be the answer.
I think C only.
So this cannot be the answer, right? So you have a lot of capacity. So the right answer, see what it is talking about is you should, when should you scale out your deployment? So it is going to be horizontal scaling, right? So when you need additional virtual machines to speed up your application. So if you see, this is the correct answer where you are saying. So is there any doubt what is out? Whenever there is out, it is going to be scaling out, and scaling out is horizontal. Scaling up is vertical. Up and out is two different concept, guys. So in up we would have, so I'm talking about this screen that you're looking at, right? So or this laptop that you're looking at. So this laptop, when I'm saying scaling up, it is meaning that I have 8 GB or 12 GB RAM in this laptop and I am scaling up, means I'm adding 12 GB. I'm kind of giving it to let's say to Yogesh or someone from the team, and then they are removing one chip and putting a chip. So that's an example of scaling up. Here we are looking at an example of scaling out. So scaling out is I have one laptop and I want two laptops. So that's an example of scaling out. Is it clear, guys? Any doubt between any of these concepts? Because this is very important. Like there would be some chapters where we would be having these questions around scaling up or scaling down. So no doubts, guys, I assume.
Yes, Yogesh.
Okay, so scaling up is, as I again will just repeat for the last time, is for going for higher configuration of the same machine, and scaling out is taking multiple machines which can have medium configuration. So let's say I have one machine with 12 GB, as I said, and if I get two machines with 10 GB each, that is an example of scaling out. Okay, so with that I kind of more or less declare that we are done with module 1 and module 2, though there are many subsections in module 2 like storage, compute, networking, that we have not gone in real detail. But since these chapters, so in chapter number 7, 8, we actually have a dedicated section for compute, we have a dedicated section for storage, and in chapter 9 we have a dedicated storage section for networking. So I'm not going to again cover chapter number 2. So I'm going to jump on chapter number 3, which is which is basically Azure architecture and service guarantees. So Azure infrastructure and how the Azure architecture is set up. That is what this particular chapter would be talking about. So in this module, what we are basically going to explore is the physical structure of Azure infrastructure. That's one thing. Then what are different service level agreements provided by Azure, and how the how like to provide service level agreement for your app. So for example, if I'm designing an app and I'm going to use an Azure component, so if I'm using two components, what would be the service level agreement of that application? If I'm using 3 Azure components, if I'm using 5, if there are 10 Azure components, so that is the scope of this particular chapter. Okay, so with this we start with the first topic. So the first topic in this particular section is called as a region. So region is a geographical area on planet. So let's say we are based out of say Viman Nagar location, and then there are few of our team members who are based out of Mumbai and Chennai. Last time we had from a few people from Mumbai, Chennai, Manila, and a lot of different locations, right? So let's assume that before cloud era, there are data centers at all these locations. Okay, so these data centers are basically called as regions. Okay, so there are multiple data centers that are there, that are placed in that region, and they are networked together with a low latency network. So there can be multiple regions. So in the next slide I'll be showing that what is a region. So in other words, regions are what you identify the location of your resources. So if I jump on the next topic, see or slide I should say, see these are the number of regions that are. So if you count from the left, there's one region which is called as West Central US, then West Central US 2, West Central, sorry, West US, West US, So there are two regions in West US. So we are having this. Then there is US government Arizona. Then these are the regions that are available. So if someone asks us, right, is there Azure available in India? Yes, Azure is available in India. As I said, it is available in Central India. It is available in Southern India, and the news as of last year was they are also trying to set up something in Mumbai. Okay, so that's what they are trying to set up. So that is what region is all about. So region is what you can say that there is a data center of Azure. Okay, and then there are a lot of data centers of Azure that are interconnected to each other. Okay, so if I again have to repeat the definition of a region is a geographical area on planet. So in our case, it is in south. So if you try to create a resource in Azure, you'll have to select a region in which that resource should be created. So let's say if you have people who are sitting in South India, okay, and most of the users are sitting there, then you should choose region as South India. Okay, let's say if you are having resources in US, then you should choose region as US. If you have resources in Europe, you should choose region as Europe, and similarly. Okay, so with this, what also happens is you can do two things, right? So now tell me, I'll ask you a question. So let's say we have three development environments, okay? Then one is development environment, other is a UAT environment, and third is our production environment. Okay, so my 100% users are sitting in India. Okay, and my 100% user base is in Europe. Okay, and then most of the users are also I would say in Europe only, like so user base is in Europe, UAT. And so can someone tell me that when I'm creating a resource in Azure, what should be my region for development environment and what should be my region for UAT and production environment?
Yogesh, for production environment, we can choose a Europe region, and for other environment, we can use Indian region.
Okay, so can you explain why have you chosen India for?
Because most of the UAT users are based in India location.
Okay, yeah. So just to kind of put it in context, guys, it's just like this region is helping you to have things in your close vicinity. So based on your requirements, so let's say if you have a lot of users in US, we should choose. So if I'm talking about this particular slide, if you have a lot of users, so you should choose either of these regions. So you have 1, 2, 3, 4, 5, 6, 7. Oh, there are so many regions, at least in the left part of the US, right? And if you go again in the east part of the Europe, there are again so maximum regions are available over here, right? So based on where your business is setting, it is always a wise idea to choose your regions. Okay, so if you look at Europe, so what we do in our team, we have most of our products, all our products or all our resources are created into West Europe. Okay, because it is very simple to understand that most of our user base is in there, but you can have multiple choices like then again if you look in the right, which is China North, then there are two regions in China, North and North too. Then in Korea also we have, and then Europe. And again, if you look in Asia, you look in Australia. So what are the other benefits of this, guys? Can anyone tell? So so there is low latency. If a user is hitting an application and if the place is over there, there is no so if I have an application which is deployed in South India, in South India region, and if the user base is in say West Central US, then just imagine that the ping has to start from here and then it has to come all the way till South India. Then the response has to go from South India all the way till here, right? So there is definitely some time that would be added. So that's the whole purpose of having regions across, and with this, it is always high availability that wherever you have, you get that particular resources. And then it is also some other term that we have seen in the first session is it is always now, right? The resources are always available now at this moment. So that's about region. And why, how we should choose region and why we should choose region. So now why is this important? Okay, so Azure has more global regions than any other cloud provider. So as we saw, right? So not many. So if you look at this, is there in China. I don't think Google has reached in China. I'm not sure about Amazon, but Microsoft has a very good presence, and Google doesn't have any presence in China. Okay, so if I have to, let's say, make a call that I want to create a product which is for Chinese market, then I have two options, or let's say I have three options: Amazon Web Services, Google, or Azure. So the natural choice would happen to be Azure, because Azure would have a lot better footprint if I compare it with any other cloud provider. Okay. So Azure has more global regions than any other cloud provider. That's one. Then this gives you flexibility to bring application closer to the user, no matter where they are, right? So wherever you are, so this is just about one region, right? But we can have our applications in multiple region, so they can kind of sync with each other. And it also provides better scalability, redundancy, and preserves data residency for your service. So data residency is what we are achieving with regions. Okay. Then there is something called as a specialized Azure region. So Azure has specialized region that might want, I mean, if you want to have some compliances and legal standards, right? So there is something called as US DDO Central. This is one of the region that is available. Then US government Virginia, and then US government Iowa, and more. So for government purposes, right, there are, based on the states, they building applications in US government, they can make use of this cloud services. There is also something called as Germany, Azure Germany. There is also something called as Azure in UK. There are a couple of things. Then there is also China East, China North, and more. So US is slightly different and China is slightly different. In China, the data should not come out of China. It's as simple as that. Okay, so the compliance standards of China is slightly different, but in US, it's more for government purpose. Okay, so if I'm talking about this slide, and if we are talking about, say, China, okay, something we are talking about China, right? So China, the data can't come out, okay, but if I'm talking about Central India, the data can come out. Anyone can access it. Yeah, so there is no real compliance standards that is been set up in India or any other country. China has high compliance standard, and in US it's for basically the government projects. They have certain compliances. So we also have the regions to support government projects in US. Okay, so any questions on spatial Azure regions, guys? And how China is a different case? So the next slide.
Yogesh, one question. For example,
Yeah.
if I have two set of users, one sitting in US and another sitting in another part of the world, and is it possible that I can select two regions so that they both can access without any latency?
Yes, yes. So, who is this, by the way? I was not able to get the
My
name.
name is Sarathi. I'm from Network Capacity Management.
Yeah, yeah. So, yeah, Sarthi. So that is possible. What we have to do is there is also some concept of paid region, which we'll cover in the next slide. So, so two regions are basically kind of pairing with each other. So, as you said, I was not able to hear you completely right, but you talked about US and India, right? So those two, yeah, yeah. So there can be a pairing mechanism through different ways, and we'll talk about that in the next slides. Okay.
Thank you.
Yep. Then geographies. Okay, so geographies are defined by geopolitical boundaries or country boundaries, right? So this is what. So like we have regions, there is also something a term which is more abstract than region. So I think by now, if anyone asks you that in which region your project is there, you should easily go in your Azure resources and see that okay, in which region my project, or if you are asked to create resource, you will have couple of points in your mind when you create a resource in a particular region. If you so I think by now we are clear with region. So a slight more abstract level of it is called as geographies. So what are the benefits of geographies is geographies allows customer with specific data redundancy and compliance needs to keep their data and applications close, right? So let's say if we are talking about China, right? So China has a very high compliance standards. So if I'm choosing China or Asia as a geography, so that is one of the case. Then geography ensures that the data residency, then compliance, resiliency requirements are honored within the geographical boundaries. So if there might be certain compliance, so if you look at if you look at this geographies, what we have, it is more from the compliance perspective and data residency perspective. And geographies are basically fault tolerance to withstand complete region failure without their connections to dedicated high capacity to withstand complete region failure through their connections to dedicated high capacity networking infrastructure. So let's say we have multiple regions, right? So if we have geographies, so what it can do is the geographies basically are fault tolerant. So if one region goes down, so there is a possibility, right? There are two US West US, right? If I'm not wrong, so West US 1 and West US 2. So it's basically for fault tolerance perspective, and I'll show you what are the geographies that we are having. See, the geographies that we are having are Americas, then we have Europe, we have Asia, APAC, then we have Middle East and Africa. So these are considered as geographies, and a region belongs to one of the geography. So each region belongs to single geography and has specific service availability, compliance, and data residency and sovereignty rules applied to it. Okay, so what this also means that every geography that we are talking about is having certain set of SLAs or compliances that it has to follow, because at different places we have different rules. So I think it is very clear that this is just a higher abstraction of regions. So a group of regions can collectively form a geographies. Okay, so we might be, if I again jump on this particular slide, so maybe if I have to just say, so this is 6 and 6, 12, or approximately 12, and then we have approximately 12, 24, and maybe 10 from here, 30. So 40 to 50 odd regions that we have, right? I've not really counted it well. I've just taken some ballpark number. But these are divided into how many regions, guys? So if you, or how many geographies? So if this, so this is basically a question that comes in for the test, that how many, so regions keep on increasing very frequently. Like I talked about the Mumbai region, which is coming up for Azure, right? So it keeps on happening, but geographies doesn't change that frequently. So if the question is asked that how many geographies are there and what are them, I think you should be able to answer that it's Americas, Europe, Asia Pac, and Middle East and Africa, which is combined a single geography. Okay. Any doubt, guys, on this before I proceed to availability zones?
No, Yogesh, good to go.
Okay, great. So the next thing that we have is availability zone. So what availability zone is? So we are clear with, as I say, like we have clear with what is a region, and we are also clear with what is a geographies. Now, what is availability zone? So availability zones are physically separated data center within an Azure region. So you have Azure region. So let's say we are talking about India or South India, right? Because that's one of the region that we have. And in India, we have two regions, if you can see in the map. So in this map, there would be multiple different data centers. So if I'm talking about a case of Mumbai, in Mumbai region, there might be multiple data centers. So let's assume that, let's take a case of our Pune GSC office, right? So let's take a case that Pune GSC office is one data center, okay, and that's one availability zone, okay. And just nearby to it, there is one more data center. You can say that I think we have also got an office near airport, which I recently got to know is. So maybe you can assume that, okay, within Pune, there are two availability zones. One is our Pune office, which is the Viman Nagar office, and other availability zone is basically the office which is near the airport. So these two things are basically two data centers, and two data centers are near to each other, and these are called as availability zones. So in region, if you have more than one data centers, it is a availability zone. So availability zones are physically separate data centers within an Azure region. Each availability zone is made up of one or more data centers and equipped with independent power, cooling, and networking. It is set up to be an isolation boundary. So if I have two availability zones, so basically if I'm talking about two availability zones, as I said, which is our Viman Nagar office and then the office near the airport. So these two are like not, I mean, they are not the same. They are separated by each other. So the major benefit of this is if one zone goes down, as you can see, the other zone continues. And the other reason to have them in the same region is like because we might be targeting to have a public which is in the same region or the user base is in the same region. So, and again, like availability zones are connected through high-speed private fiber optic network. So, in this case, we are talking about a hypothetical case of our Viman Nagar office and then the airport near office. Then these two networks or these two availability zones would be connected to each other by fiber optic, so that there is minimal latency. Okay, so this is the case of basically availability zones, and availability zone is basically your data centers, nothing more than data centers.
Yogesh, do we have option to select availability zone while spinning up the cluster?
We don't really have that particular flexibility of we choose a region, but we don't have an option to choose an availability zone because that level of abstraction is not given to us. So we are limited till region. So if you choose a
So what
resource,
exactly it helps in? What
so
exactly availability zone helps in?
right. So what availability zone is going to help in? See, for me it is West Europe, right? For let's say if I choose a resource in West Europe, for me it is West Europe. But in West Europe has three availability zones. Okay, so West Europe is one of the zone which has three availability region, which has three availability zones. So I know that my data is more secure if I put it in West Europe availability region because it is internally having three availability zones. So redundancy increases the chances of if some there is always a chance, right, that one availability zone goes down, then the other availability zone is there. So you don't have to configure yourself, but Azure would see to it that if one availability zone goes down, it continues with the other one. So while choosing, you choose till region. Uh, an availability zone is kind of under the carpet. It is taken care by Azure.
Okay, thank you.
Yep. And again, the benefits are, as I said, right? I mean, you have some mission critical applications, right? So you will choose that. So moving forward, you will also choose a region based on how strong it is in terms of availability zones. If you have just one availability zone, maybe you will say that okay, this region is not that strong. If anything happens to this region, maybe I should rather choose an availability region which has more availability zones, right? So see, this is a region, and this can depict basically a West Europe because it has three availability zones, as I said. So these are three separate, and how are they connected, guys? They are connected through
Fiber optics.
fiber optics, right? So they are connected through fiber optics. So what happens is there is again the reason to connect high availability zones through like what you can say fiber optics is to ensure that there is no latency that is unnecessarily introduced. Okay. Then supported regions. Okay, so not every region has support for availability zones, as we already saw, right? The following regions have minimum of three separate zones to ensure resiliency. So it is going to be resilient, right? The more you have, so let's say if I'm having this presentation and I'm storing this presentation at three places, that means it is 3 times resilient, better than 1, right? If I'm storing it at 5 places, then it means that it is quite like resilient. So the number of more availability zones, the more resiliency it can bring. Okay, and what Azure is trying to do is it's trying to add regions, but along with adding regions, it's also trying to add more and more availability zones. So so this is the case where it has quite a good number of availability zones. So Central US, then West US, then West US, West Europe. So we have, as I said, in West Europe, then France Central, North Europe, and Southeast Asia. Okay. So so again, like what we talked about just now. So you can use availability zones to run mission critical applications and build high availability into your application architecture by co-locating your compute, storage, networking, and data sources within a zone and replicating to other zones. Okay. So we go back to the West Europe example. It has 3 availability zones, and we are having a mission critical application, which is basically a healthcare application, let's say, and it has to be always available. Let's say someone wants to file a claim, or it is very important that he has to file it within 24 hours, or whatever is the situation. So BI products are not mission critical. Mission critical products are like which are really like related to very high availability. There can be certain cases where healthcare products are listed under high like mission critical, or there are military products, you can say. So there are a lot of different things. So in that case, we want very what you can say, an assurance that even if it goes down at one place, it is more beyond fault tolerance. So it goes beyond fault tolerance, and in that cases you can go for multiple availability zones. And availability zones are primarily for virtual machines, your managed disk, your load balancer, and SQL databases. So there are hundreds of services. If you remember, we talked about in the chapter number 2, we saw that there are PaaS, AS, and SaaS, and within each we have at least 100 services each available. In platform, we saw 3, which is like Power BI is one of the service, then ADF is other service. So all these services may not have an availability zone support. So as you can see, it's virtual machine, managed disk, and load balancer, and SQL databases. So this is a short list that is available. On the documentation, we can see more things that are available. Then there's other thing, that is Azure services that support availability zone fall into 2 categories. So there is a zonal services, and you pin the resource to a specific zone, for example, virtual machine, managed disk, IP address. And then there is zone redundant services, which is platform replicates automatically across zones, for example, zone redundant SQL storage. Okay. So either it has to be tied to a particular specific zone, or it can be zone redundant, which is a case of. So VM falls under zone services, where you have to pin to a specific zone, and this SQL database is zone redundant. It can switch easily between any of the zones that we have available. Okay, so we don't have to go much detail into it, but because it's just for the understanding purpose, and there's no interview, or not interview question, I would say. There's no question around this asked. So I would not put more stress on this point, because it is more abstract. We deal till region level. Below region, we don't really think so much. So I think we can jump on the next topic, which is called as region pair. So I think someone was asking about this, right? That can we replicate across region? So we are talking about multiple regions. So each region, each Azure region is always paired with another Azure region within the same geography, at least 300 miles away. Okay, so this is basic criteria. Okay, so the approach allows the replication of resources such as virtual machines. So here again there is a possibility. So so how are we making a? So let me understand a few basic concepts if you are clear. So how are we making a region resilient? How is a within region? How are the things resilient? How are we making it?
Using availability zones.
Yes, so we add extra availability zones, and we ensure that the region is resilient, right? Similarly, we can pair regions and make what you can say a geography. A geography can be made more resilient. Okay, So this particular case will ensure that okay, each Azure region is always paired within with other region, right? So if we go back to the Azure region slide where we have this globe, so we have four geographies, and in that geographies we have what we can have is if we talk about say Europe, we have a lot of 10 to 12 regions that is available, right? So what we are saying over here is Azure region is always paired with another region. And the basic benefit of this is this approach allows for replication of resources. So a resource within same geography is getting easily replicated across the other resource. Okay, and the approach allows the replication of resources across a geography that helps reduce the likelihood of interruption due to events such as natural disasters, civil unrest, and there are multiple cases, right? So there is something happening in, I guess, is it Hong Kong? There is some civil unrest that's happening. Is it Hong Kong or some other region? I don't remember, but yeah. So in such a situation, it can become more resilient. Okay. So is this clear, guys, that there is also a concept of pairing of different regions? So it can happen. It always happens when it is within 300 miles. So that's like within US, within Europe, within Asia, and it can also happen across. But then it can be charged, and the benefits of that is if you are doing a replication, then it becomes more resilient. That geography it becomes more resilient. Okay, so here is an example. So region pairs in Azure are West Europe paired with East US, West US paired with East US, and Southeast Asia paired with East Asia. So this is a pairing which happens within, and I'm not sure if there's also given an example of pairing outside region, but yeah, by default it is there mandatory for 300 miles away. Okay, so we have learned couple of concepts where we have learned regions, we have learned availability zones, we have learned geographies. So guys, is it clear like what is a pairing between region and what are the benefits? And it is at a cost, it is not free. If you have to pair across regions, if you have to cross geographies, then it's basically costly affair. And at times it is charged, at times also if it is very nearby or there are some benefits for Azure, then it would not be charged.
So I have one question, Yogesh, like may I?
Yeah, go please. Go ahead, please.
Like in pairing of zones, are all services included, or in like availability zone only few services we can pair across?
So it is a list which comes with an asterisk. So we'll have to check what all is can be paired. But primarily it starts with VM and storage. Those are the things that are primarily available. And but that list we'll have to check. I'm not having it handy right away, but we can check that.
Sure.
Okay.
Yogesh, I'm having some confusion.
Yeah.
As you said, like regions are also, redundant.
Within region, how do we make resiliency or make it more foolproof? To say we have in that case we had availability zones, right? And what was your question then?
My question was, suppose I put my applications and everything in Europe regions, okay? And suppose by any unforeseen circumstances, my Europe region goes down. So do I need to pay the cost to have my applications running up in other regions, or automatically Azure will do it for me?
No, that configuration we will have to do it. So, for example, see, first of all, we are talking about West Europe, I guess, or that region where we already have 3 availability zones. So there are 3 replicas of it already. Just to say, and 3 places where it is made available through availability zones. So that cost or whatever, like if you want to so are you talking across region or within region?
Whatever, both you can consider.
Okay, so let's take the first case of within region, right? So in within region case, since we don't have that visibility to us, right, then it is not up to us, it is up to the Azure services to ensure that it is always there. Okay, so within a particular availability zone, if one goes down, then the second one has to be brought up, and it's Azure's responsibility. Okay, but now if we are talking across regions. So you're talking from, let's say, West Europe to West Europe 2, which is two different regions, right? So in that case, you can do some extra configuration. So you have to do that upfront. It's not automatically done. You have to do that upfront, and then you also have to bear some cost, which is associated with the replication across different regions.
Okay, so in short, there is a cost.
There is a cost associated with it.
Okay, thanks.
Yeah, because see, I mean, they are to some extent, if you see, there's good amount of checks that are placed. When we see SLAs, we'll see that also. But if you want to be, let's say, 100 to 100% sure, then you really have to pay for it, right? That, okay, let's say this this availability zone or this region altogether goes down, then I want to create an application which is also getting replicated into other, and so that all thing has to it comes at a cost. It doesn't come for free. Okay.
Okay, and I'm just trying to narrow down the words like region. Region is just a data center. I mean, in a layman word, right? Or
So I think last time we talked about one concept where we would create certain nodes, right? So let's do that. Okay, now, so we started with region, then we have availability, then we saw geographies, and then we are now seeing availability zones, and then we are also seeing pair regions, right? So region is it can be one or multiple data centers. It can be one or multiple data centers. Okay, and when we are saying one or multiple data centers, when it is becoming multiple data centers as such, which is isolated physically, then it becomes a availability zone. One or more availability zones. Is it making sense?
yeah.
One or more regions. Geographies is one or more regions, right? And then availability zones can be one or multiple data centers. Okay, multiple data centers. It can be multiple data centers, but not physically separated. So they are in the near vicinity. And if they are connected, if an availability, if I have multiple availability zones, 1, 2, 3, and so a particular availability zones can have two data centers, and availability center 2 is also having two data centers. One is also having, let's say, three data centers, just for the sake of discussion. Three data centers, and then we have availability zone 3, and it is having, again, say, maybe, I don't know, 5 data centers. It all depends. So these three, how are they connected to each other? They are connected through fiber optics. So that's how it is. And then paired region. So within 300 miles, it is paired for extra resiliency in geography, in a geography. And it can also be paired across geography. Clear? So region is clear, geographies, availability zone, and pair regions. Any question, guys?
No, I think that clarifies everything.
Yeah, thank you. So let's move on to, so regions, as we saw over here, is these are like 300 miles away. Okay, so I mean, if you're thinking of replicating data which is 300 miles away, then you will pay some, whatever is the ticket that takes to travel from one per mile, kuch 7.5 rupees. I don't know what is the cost that needs to be traveled. Okay, I was just kidding, guys. But yeah, so the next thing is advantages of region pairs. If there are extensive Azure out stages, one region out of every pair is prioritized to help reduce the time it takes to restore them for application. So again, a case, right? In if I'm talking about a particular geography, in that we have multiple regions. So if there are multiple out stages at one region, we can create some kind of algorithm or some kind of prioritization that within the pair, the if one goes down, the other is supporting it continuously. And then planned Azure updates are rolled out to pair regions, one region at a time, to minimize downtime and risk of application out stages. Okay. So this is one thing. Then the data continues to reside within the same geography as it pairs, except for Brazil South for tax and law enforcement jurisdiction purposes. Okay, so here there is one important thing that we are, so data continues to reside within the same geography. Okay, so what we are saying is within a geography, so this is more about like pairing within a geography, right? So data resides within the same, so there are certain places or there are certain geographies which are or regions where we have to follow certain compliances. So in that this is already taken care. Okay, so the data doesn't leave the geography as we saw the case of China. Okay, now we jump on a different topic altogether, which is understand the service level agreements. Okay, so guys, we have completed how many minutes? Okay, we have completed 1 hour and we are halfway through. So guys, what I thought is we will take a quick break. Okay, a 5-minute break. So it did not went the way we thought, or I think it went exactly the way we thought, or no. So session 3 got finished in close to 40 minutes. It's not yet finished. So we are taking a break within the session. Okay. So first part of this session is done, which is the infrastructure of a cloud. Section 3 infrastructure part is done. Now we'll take a 5 minutes break and then we'll do maybe for say 30 minutes the SLA part. Section 3. Okay, and then we'll follow by a quiz.
Yes, Yogi.
Yeah.
Yeah, Yogesh. Yeah.
Yep. So guys, any questions before we jump on the next topic that you want to ask? Feel free to ask, because we have I guess 1 or 2 more minutes. Yeah, we have 1 minute to start. Yeah. Okay. So shall we start, guys? If everyone is back.
Yes, Yogesh, I think.
Yes.
Thank you. So what we are going to see now is we saw like how the infrastructure of the Azure is built, right? And now everyone should be kind of having basic understanding that how do we go about creating a resource and what can be different challenges and how do we make it more kind of efficient for our end users. Now, what is an SLA? So first of all, if anyone from audience wants to describe like what is an SLA at high level, in general, what is it? Because it's a very commonly used term, right? So how do we define an SLA and in what sense? Anyone?
Something like if we are getting failure of any services, what time the Microsoft team should come up with the solution or something like that.
Yep.
So at a high level, a service level, like a contract between the and a vendor.
Right. So yeah. So most of you have a right answer to some extent, and the very crucial thing about SLAC, everything is being rented, right? Now here it is. So initially when we had data centers, right, most of the things were with us, right? and we were taking care of our SLAs. Now just imagine that everything is rented and we are not having any assurance of it. So it can be a very risky for the business, right? So hence it is very, very important and very, very crucial that we have SLA for every service that we take, because just imagine that we have taken a virtual machine and half of the time the virtual machine is down. Then the first thing that I'm going to say to myself is, okay, forget virtual machine. I'll spin up, I'll purchase a hardware. I'll take a 20 GB hard disk, or sorry, 20 GB RAM and 1 TB hard disk. I'll work on that and I'll ensure that that service runs all the time. But it can also happen that someone is coming, and I've seen these printouts at many places on 7th floor, on 9th floor, that there is a disclaimer that is placed. Please don't close this machine. Have anyone seen these disclaimers, guys? That please don't close this machine. Please don't shut down this machine. So what is the meaning of that? There is a certain service running on it, and that service has to be made available. So it is very important, at least in case of cloud, that these services are 100% or maximum time they are available. So Microsoft maintains its commitment of providing the customer with the high quality products and services by adhering to the comprehensive SLA policy that they have, right? And then the SLA describes Microsoft's commitment. As I said, virtual machine, I want it 100% available or 99% available. Then there are 400 or so different products and services, and every product and every service has its own SLA defined. Okay, so the only thing that Microsoft doesn't define SLA for the services which are free and shared. Okay, and the services which are mostly in the beta version. Let's say there is a service which is available in a preview. So there are different kinds of previews that are available: a private preview, then general availability, and public preview, and general availability. So if it is in a preview version, then it will not have a stringent SLAs because it's just for trying out the things. Okay, so this is about SLA. Now there are three characteristics of an SLA for any Microsoft product. Okay, so imagine that you are purchasing any product. For example, we talked about virtual machines extensively. We talked about SQL database. We talked about ADF, Power BI services. So any service, right? It has three characteristics on how we should kind of the SLA is there, right? So the first is the performance target. So what are the performance targets of those SLAs? Then what is the uptime and connectivity guarantee of that particular product? And what are the service credits? So we'll see what is the service credits later on. But what is a performance targets? So the performance target for a different product. Okay. So for example, if I'm talking about a virtual machine, then the performance target for a virtual machine is that I should be connected to it at most of the times and it should be up and running. So depending on a different product, the what you can say, the performance target can differ. For example, if we are talking about say maybe Azure DevOps, right? Or if you are talking about say Databricks, so the service is not going to be available all the time, right? It can also go in the downtime, but you can establish a connectivity and you can again bring up the service because it is on demand. So those kind of things can be there. So I'm not able to give a right example at this moment, but just try to imagine maybe in future when I come across more products, then I'll give an example where at different places we are kind of guaranteeing uptime, and at few places maybe we are guaranteeing connectivity, or maybe few people from the audience can throw or share their examples that at what time we can have different performance targets. So one of them can be uptime guarantee and the other can be a connectivity. So first of all, is it clear that I mean, based on the nature of the service, there can be different performance targets? Okay, so if I am just not able to come up with an example, so I thought if anyone is in the audience who can think of an example, that can be of use. Okay, so the next thing that we are going to talk about is see uptime and connectivity guarantee, which is the second important aspect of a particular SLA. So the typical SLA, I mean performance commitment, it can be like 99.99% available, right? Is there thing. Then the other thing is this is called as 3 nines because it is 99.9, and then the other is called as 5 nines. There is also 9 nines. So every different service is having their different targets. Okay. Then as we said, right, that we can apply performance criteria of uptime or response time. So there can be a performance criteria that it is either up or it is the based on the response time of a so if I can think of I'm not sure it is going to be 100% that way, but if I am thinking from the database connectivity, most of the time that it has to be, there has to be connectivity as well as uptime of that database and or let's say I mean if or if I'm talking about say application, okay, then I'm more concerned about the response time of the application, and we should be concerned more about the response time. So maybe for the next session I'll come up with a better example, but for now there can be just try to understand that for different type of services there can be different type of nature of the performance, and these are some SLA numbers that we have. So how do we calculate a SLA? So before we see this, this is basically the downtime for various SLA levels. Okay. So when we say that an SLA is 99, what it also means that the downtime per week is 1.68 hours, and the downtime per month is 7.2 hours, and then the downtime per year is 3.65 days. So essentially, when we are saying that a product is having a 99% SLA, so I'm not sure which one has that 99% SLA, but maybe let's assume it is some product, random product. Then that means that for 4 days in a year, uh, the product can experience some downtime. That the product is not available for 4 days in a year. And if it is 99.9, then it is like say only 9 hours in a year. And if 99.95, it's 4.5. And so 99.99 is quite good, where we are saying that it is it's 5.26 minutes downtime per year. Okay. So any questions, guys, on these SLA? Because different product that has been offered by Microsoft, every product has a different SLA. So if we are choosing an application that we want to be up, say 99.99, then we can't choose a product which is available 99%. So we'll have to choose a product which is also available 99.99 times. Okay. Any questions, guys, on how? I'll also show you a calculation that I've come up with, which will help you to come up with some random examples. So this is how we kind of come up with this calculation. Okay. So what is 100% uptime? Okay. So 100% uptime is like 365 days. It's up, right? Then how do we calculate, say 99.9%? Okay, so 99 point, this was the example, right? 99.99. So 99.99 means that it is just 1 hour, right? Is the downtime, like which is like 52 point. So there is a sure shot exam question where we are asked to calculate different SLAs. So this is the calculation that you can refer. So 99.99 means like how do we calculate what is the downtime for 99.99? So you can say that 99.99 into 365 divided by 100, which is 364.9635. Then you subtract this value from 365, which is 0.04. Then you again say that okay, one day is 24 hours. So what is 0.004 days means? And 0.004 days means it is 0.96 hours, which is approximately 1 hour. So there are different questions that okay, if a product has a SLA of 99.9, what is the downtime of that particular product? So though that is been given in this thing, there can be a combination of it. There's also a composite downtime that is to be calculated. So any question in this formula, guys? So, hello.
No, Yogesh.
No,
No?
Yogesh.
Okay, so I think this is one of the very important feature. Then what happens if Microsoft doesn't follow these standards? Okay, so let's say Microsoft has assured. So I don't have a list right now with me that which of the product adheres to which particular SLA percentage, but most probably it's the VM that is adhering to 99.99. That's the standard for a virtual machine, that it has to be, if it goes down, it is only 52 minutes in a whole year that it can go down. So this is one of the very important benefit, guys, that we have to understand, right? So at times we put this particular important notes on our on the desktop, right? That please don't shut down, or just imagine that we at our data center are taking care of the uptime, okay, and we are hiring our own admin people, our own, and they are ensuring this uptime. So isn't that more of an headache, considering that Microsoft takes care of it and ensures that it's always up? Because a network can go down anytime, or a hard disk can crash anytime, and despite of everything, they are more or less assuring you that they will ensure that this is the level of service. So I mean, if I look at from the uptime or SLA perspective, it's always good to rely more on the cloud, because it's someone else's headache, not our headache. And if they don't follow that, right, then we ask them for a credit. So SLA also describes how Microsoft will respond if the Azure products services fails for the governing SLAs, right? So let's say those SLAs are not met. For example, this is a case. So if you can see, so 99.99 SLA, if it is less than that, so if they are giving some assurance and the SLA is less than 99.9, then they will give us a credit of 10%. Okay, if it is less than 99, then they'll give a credit of 25%, and if the SLA is less than 95, they'll give us a 100% credit. So that means we would be not charged for that in that case, if it is 100%, right? So guys, any question on this aspect?
Yogesh, these service credits are in dollars or what?
Yeah, so I mean, it is basically every product. Let's say I'm taking a virtual machine, right? So virtual machine has a particular cost associated with it, and it can be in anything. You can convert it in dollars or whatever. So for 1 hour, if I run a virtual machine, let's say the cost is $20. I don't think it is that, but I'm just taking an hyper number. But let's say within a year, it so happened that if I'm not wrong, 99.99 is the SLA for virtual machine, right? And it so happened that the virtual machine was unavailable for 4 hours. Okay, so that means it did not follow 99.99, right? It followed 99.9. So that means I'll get a credit of 10%, which is going to be, so let's say my fees is say $2,000 if I'm putting it for per year, and in that year or in that month, if I'm not getting that SLA, then they'll give me 10% less is what I have to pay.
Okay, understood.
Okay.
Yes, Yogesh, actually here one question. Who will be maintaining this record, like 99% achieved and 99% is not achieved? I mean,
Yeah.
so it's a Microsoft that they will be maintaining track of this, or that's the person who is taking the services, he has to maintain this?
Yeah, so there is a concept of there is a monitor that is also provided in Azure. Over there also we see the health of all the services. So so we have to, so it doesn't happen automatically. We have to kind of reach out. We have to make a case out of it. We have to show it to the Microsoft that see in the Azure Health Monitor, we are seeing that this particular service of a virtual machine was assured to be having 99.99, but it is only 99.9. So these calculation that we have shown, right, is for that purpose. So we make use of this calculation and find out that how many hours it was actually down. if it was assured this and it was not done, if it was not that, then we can also take a help of the Azure Health Monitor and raise a request, and then they will do the credit. And in the next billing cycle or in the same billing cycle, we'll be getting that credit. So it is our responsibility. No one from Microsoft is going to tell us that, okay, we were down.
Right. Yeah. Thanks.
And in fact, they will also, I mean, we also don't tell, right? If our certain features are not working as an application, we never tell that unless a customer
Right.
discovers
Right. I
it. Then.
got it. Yes. Yeah. Thanks.
Okay. So is everyone clear about the three aspects? So one aspect is like uptime, downtime. So first aspect is that there's something like an SLA which can be calculated on a performance, and then a performance can be defined either on uptime or on response time. And in the next session, I'll come up with a slide where different services, response time and uptime SLAs are shown in a proper picture. Okay, so that it is more self-explanatory rather than imagining, because I am not able to, as I said, right away come with an example. And then the third aspect of it is a service credit. So if someone is saying that uh, the SLA is not followed, then they'll have to pay for what is, what they have not offered. Okay, I think this gives us more ammunition, right? Because what I've seen is many times, even in your case, Venkatesh, right? There was a particular case in which we did not got the service of usage metrics. So you go and check the Power BI SLA, Power BI service SLA. And if the Power BI service SLA is not meeting it, then you can get that credit, whatever you want. And then we can both have party using that amount.
Yeah, yeah, true. I need to check that. I will do. Yeah, good. Thanks.
Yeah. And this is the case with everyone, guys. What I've seen is people are not aware that if certain service is not available, we can get a credit. So that has to be made aware. Everyone has to be made aware of that. And so this was just a joke, the party one, but we can raise for a credit, guys. That is very important. Okay. So moving on to the next slide is. So let's say we have two products, right? We just talked about one product, but let's say we have two products. So two products can give a composite SLA. So we have just take a case of web application. So web application has an SLA of 99.95, and say SQL database has an SLA of 95 and 99, right? Now, how do we calculate a combined SLA? So because these two are working in a combination, it can't work in an isolation. So in such cases, the combined SLA is calculated like this. So 99.99, that is one, and into that it's multiplied, and a combined SLA is calculated, which is, if you see in this particular case, the combined SLA when you use two products together, it is less than a single product SLA, because single product SLA is 99.99 and this is 99.94. So guys, can we take an example that what I think everyone should take this example, because this is a sure shot exam question in so what is a SLA, what is the downtime in number of hours or number of days when I say it is 99.90. So at the end of the session we'll take that, but essentially this is we'll do some math at the end of it, considering that it is going to come for an exam. Okay, so this means that the combined SLA is down, right? It goes down by say 0.1%, right? In this particular case, because web app was higher and database is much higher, but the combined is 99.94. Okay, now what do we do if the combined is low? So in that you can do something like this. Okay, so let's say you have a web application which is primarily dependent on database for its usage and providing some guarantee. But if it is going down, then the combined effect is of 99.94. Now, how do we ensure that it is not 99.94 or something better? Is there in such cases we can have a database and we can have a queue, and there we can make certain calculations that both of this can't go down at the same time. Okay, so one is 99.9 and other is 99.9, and then we get a better SLA that which is say 99.99 I think. I don't have a calculation for it right now, but maybe in the next session or by the end of the session, we'll see that how do we calculate the SLA. But a composite SLA is calculated by simple multiplication. This SLA is slightly trickier. We'll see how it is calculated, because here we have to see, because there is no right answer that when exactly both of the applications can go down, right? Either SQL database can be up or queue can be up. And what the way we are designing our application is either of one it can be. So if the web application can put data onto database, and if the database is down, it can put it on queue. And when the database comes up, the whatever information was stored into queue is replicated into the database, and then it becomes up all the time. Okay, so this is the design that we are proposing. Any questions, guys, on the composite SLA? We have not seen the calculation, but it is more. I mean, it will definitely give more SLA than the previous SLA, where we are considering two combined one. Okay, I'm going to skim some of the things. Resiliency is the availability. Okay, then cost and complexity versus high availability, and okay. So resiliency, we'll quickly talk about resiliency. So resiliency is basically the ability to for the system to recover from failures and continue to function. So this is basically the same thing that that we saw when we are talking about disaster recovery, right? So we can't say that an application is always going to be available. There would be certain situation in which the application goes down, but how do we make sure that the application is made resilient? So we have to what we have to do is we have to design applications in such a way that the applications, like we saw this case, right? We have designed application in such a way that if the database is not working, then it is going back to the queue. So that particular architecture has to be taken care by us, that while we design an application, we are designing an application in such a way that it is not only based or it is not only dependent on one only one product. It can be dependent, or it can be designed in such a way that it is having inbuilt what you can say disaster recovery. Okay, that's basically the definition of resilience. And what it also says over here is as a guidance is, so you have to understand failure mode analysis of your particular project, right? So in our case, we understood that database connectivity, database downtime can be a failure mode. So we have to analyze that, and we have to create a backup to it in terms of queue. So the queue and database both can also go down. Then we have to create a backup in terms of file system, and file system also can go down. Then we'll have to create some more backup. But essentially what we are saying is everything can't go down at the same time, and then we have to create certain fallback mechanisms. Okay. Then what availability refers to is to the time that the system is functioning and working. And couple of aspects over here is we have to kind of look for system where just give me a minute. So the most providers prefer maximum the availability of their Azure solutions by minimizing the downtime. However, as you increase the availability, you can also increase the cost and complexity of your solution. So as you go up in terms of availability, like if you put products which are more high on availability, it also increases the cost, is what it says. And then consideration and defining of SLA. So this is more of a theoretical part, so I'm kind of skimming through this quickly. Then the other aspect of this is the Azure solution must be self-diagnosing. Yeah. So the other aspect is what it is saying is when you are having very high availability zone, high availability applications, then you really have to design application in such a way that you have to have applications defined in self-diagnosing mode. So for example, the application having three different sources: database, queue, and file, right? So we have to create application in such a way that the application will keep on pinging the database. Okay. If the database is not available, then after some time it will go and ping to the queue. And if the queue is not available, after some time it will go and ping to the file. So this should be considered as a part of our design application, so that we really have a very high application uptime, which is an application uptime like 99.99 or 99.999, which is just like 52 minutes of downtime. Okay, so this is what it's talking about. So guys, any questions on SLAs and how do we? So combined SLA is simple to calculate. So I think we can do two things if you don't have any questions. Any questions, guys, on SLA before we move on? So let's take this quiz that we can either do it now or later. So what is the downtime of 99.90% SLA? This can be an exam question. Okay, this is one exam question, and then the other exam question is simple, which is 99.9 is one SLA, product of one SLA, and 99. Say 8 is the product of one SLA. Then what is the combined SLA? In SLA and calculate hours. So can anyone explain me how will we calculate the hours, downtime hours for 99.90 hours? Because this is most probably going to come. I got it during the exam, so I thought we should talk a bit about it. Anyone?
We'll multiply it by 365 number of days in a year. Then it will give us days, and subtract this from 365. It will give the number of days. So we'll multiply it with 24. It will give number of hours.
Yep, and then we'll calculate. Yeah, so we'll calculate the hour, and then we'll come up with the downtime. Yeah, so this is the right. Yeah, so this is a short possibility that we get, and then we also get a combined SLA. So and this I think it's just a multiplication. So yeah, so this brings us to the end of our session, and now we will just get a quick quiz on this. So let's see what we have. Okay. So first of all, in terms of summary that we have seen, okay, let's see, let's read this, okay. So this is with over 54 regions, right, that we have. Microsoft has 54 regions distributed worldwide. So can anyone tell me how many geographies do we have?
4 geographies.
Yeah, four geographies, right? That's correct answer. Because this keeps on changing. Maybe after every certain limit time that they keep on adding the regions. So that is going to be. Then Azure also has a dedicated region to support government usage. So we saw that there is something called as US government cloud. Then there is something called as Germany. Then there is also in Europe that need to be deployed in China also, and you can ensure that the data security and residency is met because in China no one can enter as well as no one can exit, right? So the data has to be there. So only Azure, I think. I'm not sure about Amazon, but Amazon, let's say if AWS is in China, AWS service in China, Beijing. Okay, so AWS has a service, but Google is not in China. Is the last, because we did a RFP with all the 3 service providers sometime back, and let's see, Google is also developing Google. Okay, but the last it was not. I need to check whether it is there now. Okay, so that's one thing that we have to see. Okay, then we saw about regions, geographies, SLAs and all. Okay, so now let's take these 3 questions. Okay, so deploying an app can be done directly to what level of physical granularity? Anyone?
Region.
Yeah, region.
Region. Okay, let's see if the answer is correct. To use data centers that are made available with power, cooling and networking capabilities independent from other data centers in a region, choose a region that supports.
Availability zones.
Availability zones. Okay. Is there something called a geography distribution? There's nothing like this, right? Okay. Then what is the third thing? Application availability refers to what?
Service level.
C option.
Is third one? Yeah.
The services agreement of associated resource, the application support for availability zone, the overall time that system is functioning and running. So there's I got two answers. I got two answers, but there was one which was this also. Someone also said this, right? So should we choose three or should we choose A or C?
C.
Should
So overall
C?
time that.
Okay, so let's check this. Yep, everything is right.